Everybody, thank you for coming.
Maybe Julie.
Before we begin with everything, may I please ask you to turn your phones to silent, because everything is recorded and etc. But hey, my name is Allar Allas, and I'm a CTO at a company named Inspirators. So, a couple of words, who I am and why am I here. I wrote my first line of progress code in year 96, if I'm not mistaken, and then had a blast for 4 years when I went to the other side, Java, etc. After that, I had a short rendezvous with Progress again in year 2008, where I used Progress as a database to host star scheme, meaning that I optimized a report that ran whole night into a couple of seconds. I secretly love ADL, this must be also said. And why am I here today is that lately we started again with Progress. Much has changed over those years, and now one of the challenges is how to bridge different systems, with Progress usually being a core system that is solid, quite heavy, with history, and people who know the application through and through. I, on the other hand, am focusing more on the cloud technologies. And the reason why I'm doing that I create a lot of small application for customers that first serve as a prototype application, meaning that you have to deploy something fast in order to know whether it's good or not and how to switch customer, etc. What else? I found a good picture to illustrate what I'm focusing on. On the left, this is a console for the flight mechanic on the plane B-36. It looks quite complex. It has a lot of gauges and switches, and what it else has is that if you actually know what's in there, then that complex picture becomes quite clear for you, right? This is basically the complexity, but you can tackle it, right? On the plane, there are, if I'm not mistaken, 5 or 6 such places to work. On the other hand, picture on the right, this is a modern plane, meaning that one person can actually focus on the task at hand and is actually networked too. So I think while those pictures are a bit exaggeration, the thing is that the expectation to the cloud is that it is kind of easy to start with, right? And what else? If you are talking about kind of bringing some new functionality to your ecosystem, like you have a core system, and then somebody wants some small thing to be added there, then what you actually would like is that the added thing doesn't add to your complexity, right? So that it's kind of a very clear separation between the core system and then everything else. And that's something that I actually then I'm focused and would like to present to you today. This is what we will be doing today. So basically, just to simplify, we will have the core system that has operational data, and we will then try to build a pipeline that actually allows you to segregate the responsibility so that on the core side, you will have a very clear part that actually communicates the world, and you will not have the complexity of implementing some business features that are required for the satellite system, right? And I don't know, I don't think I need to tell you why this is important, because we all know those systems that become quite a mess, and you, at some point, you basically are not able to tell which part of your core functionality is actually used in production and which not, right? So, and one other important thing is that today we'll be talking about event-based architecture, meaning that, how to say, we are talking about one pattern that will allow you to break down the big system in bit smaller parts. And the pattern that we are discussing today here is basically the read model. Can you please show with your hand who knows what is the read model, that architecture, and who has implemented one? Right? Okay, so I will briefly explain that one too. So the read model is something that is used for reading the data, right? So, and this is then built and populated on that place where the data is actually consumed. For example, if we are talking about the satellite application, then the read model will be created and compiled and updated there. So that basically your core system throws up the event that, hey, something is changed. The event is listened by the satellite system, and the read model is updated. So in that way, things are very much decoupled, and as a core system programmer, you couldn't care less how it is implemented there, and you will also kind of save yourself from all those scalability issues, because you just put one event to the pipeline, and everything else then is updated automatically, right? So things that we will implement today, it is simple and demonstration, but I think it would be useful to see how to chain everything together. So let's proceed. So the stack. These are the components that I used, for example. We are using the Kafka CDC. This is or the OpenCDC. This is a hot topic in this meetup too. Kafka is a hot topic. I think there will be good lectures today, in this program that explain the CDC part and Kafka part in good detail. And then this was the yellow side, and on the blue side, this is then the satellite system. So this is an example stack that, let's say, any modern software company can provide. So in that sense, I'm basically picturing what you can do and what to expect from those other parties. Or if you want to tackle the modern frameworks, then even better. So shortly, yes, we are using a simple CDC table. I'm looking at CDC like something that basically fills some table that can be used for moving the data and having those bookmarks, what is already read and so on. Then we will use two simple connectors. One is for the OpenEdge, and other is for the Mongo. And then I will basically show the simple read model and how it actually arrives into the sample web application. Right? So let's proceed. A note on the cloud. This is since my last rendezvous with Progress was quite long ago, then I must admit that I couldn't manage to put OpenAge in the cloud for this presentation. This is currently running on my machine and so on, but everything else, this is cloud-based. And what I mean by the cloud is that those are the providers that manage everything for you, meaning they provide all kinds of the configuration services for the security layers, they provide the scaling, they provide the connectivity with other cloud, etc. So because of that, those are kind of considered cloud, and this one is the classical something that you can put in a container and then upload to the cloud. Okay, and a couple of words why I emphasize the cloud is the same simplicity to actually onboard anybody. I think one of the challenges for the total development is to find somebody who's actually doing the work. And if you are having those requirements that kind of need you to write to settler systems, then you also want to scale your development capability. And in that sense, the cloud allows you to start very easily. At least some services in the cloud, not everything, of course. Yep. Now let's get to the good stuff. So let's start somewhere, and I think the somewhere is applications. I built a sample application, and what it does is that every time a data is added or changed in the Progress Sports 2020 database, then the data is then delivered over the pipeline to this application. So, and that's it. In order to basically show that we have a changing and moving data, let me bring on the application, and then let's make a change. Let's say that I would like this order to be filled today, right? So, okay, so here it is. And then maybe let's go shortly over the pipeline. Let me ask you, how many of you have used the CDC part of Progress? Okay, of course. Yeah. So I will not go into details, but from my experience as a very fresh to Progress now, I would say that it was easy. So basically, I needed to write one file that defined those areas, a couple of configurations, and off we go. Basically, we had a table in Progress that was updated on change. So, for example, this is the same So, in that sense, the CDC part is easy. And how it works is that the CDC kind of creates the log of changes, right? It's an ordinary table, it's a log, and you as a consumer or somebody who wants to get all those events from CDC table, you just have to pull that table and check if something was added from a certain bookmark on. So in that sense, this technology is quite straightforward and easy to use. So you can decide if this is a strategy for actually exporting the data, or would you like to communicate with Kafka directly. But just to start with something, this is great. I mean, for me, it was easy. And then what else? Let me show you maybe. Right? Guys, hands up. Who has used Confluence before? Okay, good. One person. So Kafka and Confluence, this is basically as a cloud provider, and Kafka is basically a message pipeline solution that persists and guarantees the order of messages that are put in. The later part, this is very important, so that you can actually rely on the fact that if you put the events in that the Kafka in one order, then you will get those back in the same order. So if you don't have the feature, then you will probably have some interesting business logic errors in your application. But yeah, this is great. And all you need to do in order to do some simple solution with Kafka is to create two connectors. One is, there are two terms. One is source. This is something that produces the data, and other is a sink that then consumes the data. And all you need to do is to basically create source for progress. This is a GDBC configuration, and it's as simple as that, right? You have to know how to write the GDBC URL, right? And other is then the sink connector, which basically is very similar, just that you also then need to point out what data do you consume, and then same way just to provide the URL, right? Good. And with that, you will basically have the pipeline that delivers messages from Progress to Mongo. This is all. So I forgot to mention one housekeeping note first, and it is that the QR code that was in the beginning of the presentation, this points to the GitHub repository, and you will get the demo code there. And in case you have any questions or want to suggest something, then this is the channel. I'm all ears if you have questions on this topic. And this was then the Kafka part, and now let's look at the Mongo part. For that I use managed service. This is a Mongo Atlas service. I like it because you can have, for development purposes, enough resources, meaning that whatever you do, you will probably not run it down. The downside is that the free tier doesn't have any backup, so don't count on any live applications. But in this example, this consists of two things. First, this is a table or collection, like the Mongo is saying, and as you can see, this is then the data that we actually changed in the progress database. So, but by this we currently have the pipeline which exports the data here. And if we are now talking about actually the real or the proper implementation, then here you would write the logic that transforms the data, puts in some views or uses whatever else. But for example, we use just this table to display or front application. However, this is important because it shows that the same assumption that the complexity of interfacing with those satellite systems, this must be on the shoulders of the satellite system. And here it happens. Here they get the data, and here they can implement whatever the transformation that they need with the data. So basically just hand over the data, and after that it's easier. All right. Then, yeah.
Are you using one table and one topic, or are you putting all of the changed data onto the same topic?
Only one table. This is configured for one table. Yeah. So if you are developing a real application, then you actually have to put some thought in that how to design that. And you have to also implement authentication, authorization, etc., etc. I'm just demonstrating the pipeline here. So don't mistake the simplicity for the actual complexity that is needed. And what else from that cloud? Can then basically, for example, implement a REST API. Here is a serverless service, and you can write those serverless things as easy as that. You have basically the web-based option to write code, but I prefer to actually use it on my development environment. So this is basically the node-based thing, application. Each time you write the code, the node application is deployed again. So, but yeah, it's quite easy. Now, let's get to the front end. Again, the hand raising part. How many of you have used Self or Self-Kit? Good. If you haven't used, then this is a very, very good option. It is valued because it's a quite low learning curve, and you have to write a lot less boilerplate code compared to, for example, Angular or React or any other things. So this is a very, very good place to actually start your framework journey if you already haven't. But yeah. And the Svelte code is then nicely available in the repository. So let's go to the good part. Now the code that fetches the data on change is here, right? So basically all you have to do is to point out what you would like to listen. In that case, I'm pointing to the same table that you already saw here. And each time there is a change, each time then this one updates the data, right? And yeah. So let me see what else. So, guys, I will ask you, from that pipeline, which is tech stack or as a point what you would like to hear about today? So, okay, let me show you something, one cool thing. So, this is our application, right? Let me maybe run through how to deploy that application, right? So that you will kind of have end-to-end. So, as far as the deployment, let's use that one. So, why I like this platform is that when you write your front-end application and deploy that or push that in your GitLab or GitHub, then you just have to point out the repository address, and it is able to deploy all by itself in its simplest form. You can also then basically to segregate what is a production branch, what is a testing branch, what are those feature branches, etc., etc. But in order to do that, all you have to do is basically say that let's add a new project, right? And here this is already connected with my GitHub account, and then I just can press import application. Everything is detected, right? I think maybe here we should enter some environment parameters like so, and by all means, go ahead. I already did that. But yeah, this is basically the thing that I did previous time, and this results you then the deployed application, and you are able to share it. So, for example, if we have that one here, then first we have the like the main version of the application, and then we have those deployments, meaning that each time somebody pushes something in the repository, then an instance is created, and this can be then used for testing. Right? For example, if you are using Jira, then you can integrate with that perfectly, and each time some feature branch is created, then this is also then bound to that feature branch, and testers can also then very easily find that, hey, this is a deployment that we need to test, right? So good. And, yeah, in order to show that this is working, this is working. Okay, so let's make it a bit more interactive. Do you have any questions? Kind of everybody seems kind of baffled. Either this is a boring part or this is a baffled part. So which is it? Yeah, please.
There's a microphone in the room.
can we maybe see how the data is structured in the MongoDB as compared to how it is in the original Progress database?
Good. So let me say so that the good thing is that you don't have to structure this data in Mongo. You can kind of fixate the data later by applying a scheme. You can generate a scheme based on the data and apply that in your program, but otherwise, no. And the first big difference is that this is not a relation, but a database. It can be used for describing some relations, but it's not. It's a document database, meaning that you can put the data in however you want. I'll make a good example. So, for example, you have some data per customer on a monthly basis, for example. Let's say those are transactions in the bank. And you would like to kind of provide them for some application, etc. So you don't have to store the data row by row, but you actually can store the data so that you have a reference to the customer, you have the month, and then you have array of those transactions. So basically, the customer data is then provided in monthly chunks. What is it good for is that it's easier on the database, and most probably you will be perfectly fine from application side too, that when you have the monthly data presented in one chunk. So it's a good way to kind of optimize the data so that you will have lesser reads from the database, right? And this is also related to the same idea of having those read models that you kind of pre-populate the data. With relational database, you kind of query the data every time. You can buffer it, of course, a bit, but otherwise this is still a read. But with all those rows. But with the read model, you try to compile the data unit so that it contains everything that you need, right? Okay. Yeah.
So my question is, how do you handle unstructured data? Things like pictures, JPEG files, and displaying it via this same mechanism.
So basically, I don't think it's a good idea to store binary data in a database. There are other services for that. But otherwise, if you have a kind of data with unknown or unpredictable structure, then you just can write it in the collection. There is no kind of restriction to write anything that you want. You can analyze the data afterwards, meaning that you will get the statistics that what data, what columns or data fields are present in the collection, right? And how many of them, and that you will get kind of the picture that what is the quality of your data. But otherwise, all is fine. You can basically write everything in the document. In that sense, it's a kind of the developer responsibility to have your data in order. But for me, the big plus here is that when I develop something, then at least in the prototyping phase, I don't have to write or define the structure. And because during development the structure changes, right? And only after some time, when the functionality kind of settles and becomes solid, then it makes sense to kind of fixate the structure and apply some schemes to verify the data before it is saved to the Mongo. But I think the part where you can prototype fast, this is very, very good. So let me ask you, the concept of having those satellite systems, how many of you have such case where you kind of have a lot of those smaller applications around your core system? Everybody who has more than 5, please raise your hand. So yeah, I think why this kind of connection with other kind of databases is good is that you should be able to enable those development of those third application, and kind of when you plan for those applications, then maybe this kind of solution takes some questions off your shoulders in terms of how complex it is or how costly it will become and so on. So kind of the idea of focusing on the light interface, I think this is a future part. What else? And the event-based architecture. Maybe I will cover one more topic, and this is how to kind of get out some functionality from your big monolithic system. And this is basically the event-based thing, that you start to emit the data from some business functionality part, so that you will kind of have the mirror of the data flow in the other system. And at some point, you basically feel solid enough to switch off the part in your core system. So, for example, if you have something that you consider legacy, it is written for some functionality that is not longer used, or application that is no longer used, and you would like kind of, or even more, or if you want to kind of verify what parts of your code or of core system are used, then if you migrate your satellite with help of those event stream, then at some point you will kind of can analyze which part are used and which not.
Yes. We have a question. How did you do the initial data population? Obviously, you're using CDC to keep up with the aggregate changes, but how do you do that initial population of that order table?
Here I didn't, right? But if I remember correctly, then you should be able to configure the progress CDC so that it will populate the CDC table. I hope I'm not mistaken. But you basically are able then to create a mirror table that has the data. Yeah.
Any more questions?
So, but then let me ask you. When you decided to come to this lecture, then what was your expectation? Did I meet that expectation, or do you have still some topics that are maybe not that clear? You all look so thoughtful today.
So reason for coming was getting an idea what MongoDB, how it could be integrated somehow, and what the use cases are, and where it has advantages over using an open edge database for some things. So gave an idea.
So I think how I see it is that usually the functionality that is written in progress, this is a core of something. This is in some cases 30 years kind of layer on layer, and it works solidly. I know quite many applications written in progress that actually perform up to this day, but I think the issue is that when the need for the additional functionality increases, then you kind of have a challenge how to manage the complexity so that your core remains kind of quality and not bloated. And I think this is one good way. Just you kind of just can delegate some things to other guys, right? And I think one good thing is that once you kind of start sending events to the Kafka pipeline, then actually multiple consumers can use the same events, right? So in that sense, yeah, for you, let's say the contract is to provide the event that's the data, and everything else then can be delegated to somebody else, right?
3 minutes left.
Yeah, please.
General report for all people that want to generate reports on the main database?
Yeah, of course. So CDC, I think one of the talks in this program will be how to use the CDC for reporting. And it's a great use case.
Can you use MongoDB for creating reports? The customer wants to create his own report on this MongoDB.
Yes, of course.
Okay.
Of course. So it has in addition to also the data transforming action that can apply, it also has a charts part where you can write those nice graphs, etc. But I think when we are talking some reports, then it can act as a source for those report systems. This can be something that gets that event data, transforms into the data format that you need, and then this can be consumed. Right. Okay, thank you very much.